everyone. So we're students at Georgia Tech. We're located in Atlanta, Georgia, and we're here to talk to you about a course that we are in, which is ME 1770 Intro to Engineering Graphics, and it's basically a class where we learn about various software used to model and design parts to construct a real-world device or machine. So we're mechanical, civil, and aerospace engineers, and we can't wait to introduce our project to you.
Dr. Dix is a very disciplined, specific professor. He does his best to prepare you for the rigors of this course. There's a lot that's going to go on to it. So he may seem a little bit strict at first, but this is all just to keep you, make sure that you're hitting the deadlines when you need to hit them. So like I said, take him very seriously. You will have a lot of fun throughout this course, Dr. Dix. It can be a lot of fun, but just make sure that you learn from his discipline.
The main project that we've been working on this semester is a 3D CAD project. We were assigned to modify a design from the previous semester. It's an all-terrain vehicle that runs off of alternative energy. This was done, we have 3 different sections that have been working on this. Each have made their own unique improvements to the previous design. We used Autodesk Inventor in order to accomplish this. It's a software where you can start off with sketches and apply dimensions, and then you can do things such as extrude and create 3D features that you can modify to change your design.
The group consists of 3 teams, which we all work together and regarding making constraints on the vehicle. The primary changes was each team was responsible for making some changes to the cabin of the dune buggy, the engine, and the track and propulsion system. So the track was done to improve the vehicle to be able to perform on very uneven fields. We also added a propulsion system for dune buggy to be able to fly, and this was done by installing 4 turbojet engines on tracks and 4 different directions to be able to fly in different angles and hover as well.
This is section D, and the changes that we made to the original dune buggy was that we added tracks to it instead of 4 individual tires, and we also added a propulsion system that can lift the dune buggy into the air and get it over any sort of terrains. And so the importance of this is, one, we looked at how can we improve the dune buggy. One of them was we noticed that a dune buggy, if it gets into a really bad fog or anything like that, it can get stuck and the tires start spinning. So we fixed that with adding tracks, which simply adds more surface area for which the tires are going to be gripping the ground, be able to get it through those types of terrains. As far as the propulsion system, there are times that even with tracks that's still going to get stuck. So the propulsion system allows us to simply fly over the obstacle that we're running into. So the part that I worked on was the track design. And what I did is I just searched the internet and researched and found different types of track designs, and I based my model off of that. The track system, it's a track that wraps completely around each rim, so it goes to the length of the dune buggy. It just simply adds more traction for the dune buggy to get through any obstacle. My model for each individual track consists of the base of the track, the inside of the track, which is a skeleton which adds support, and then the top of the track, which will actually be touching the ground. In addition to that, each track is linked to the next track using a link that works on the outside of the track, and then a pin that will go all the way through the tracks, and then a bolt coming up on the other end, which will tie it all together. The next part is the ring assembly.
My part is ring, the return roller, and the wheel ring. The wheel ring is acting as a wheel, and at the same time it supports the track itself. At the same time, the dune buggy is walking on the ground, it acts as a wheel and start turning the track in order to proceed. And at the same time, there is a return roller at the middle of every two rings in order to maintain the shape of the track. The ring simply looks like a ring with teeth that can connect to the track to pull the track to move. So the ring is designed to hide a propeller inside of the ring, which will be introduced by Niet later.
Okay, as it was mentioned, I was in charge for designing the propulsion system for the dune buggy. The propulsion system was installed with doing that to make it to be able to run and park. And the constraint was coming from the outer band and the upper band. So we had a limited amount of band to work on and pick the right engine. So I did some research on it and found the right turboprop engine, which is being used often. And we originally decided to go with 3 turbojet engines, and we finally figured out that 4 would be much suitable to maintain the stability of the unit and to power it. So the turbojet system consists of the air intake system, which consists of the propeller, and then the air will go inside the compressor to compress the air and increase the temperature. The increased high temperature and high pressure air will go through the combustor to add the fuel on, and that fuel is going to burn and produce the thrust by going through a conversion and diversion nozzle. The cooling part was added to the combustor in order to avoid any sort of melting of any parts. And by changing the thrust vector of the propeller and the engine that comes out of it, we will be able to change the direction during the flight and be able to help with the same.
I designed a new drivetrain for our buggy. The drivetrain's purpose is for the engine to deliver power to the front and rear axles, which then in turn deliver power to the tracks to help the buggy move. The drivetrain consisted of a front axle, rear axle, drive shaft, and a joint piece connecting the front axle to the drive shaft and the drive shaft to the rear axle. The joint was specifically designed in order to handle the stress and power that would be transferred between the axles, and to be flexible as well to handle the different kinds of terrain that the dune buggy would be going over. The rear axle consisted of a differential that was specially designed for this buggy in order to deliver maximum torque to the tracks. And all these parts were then put together using an inventor.
Section M focused on modifying the frame and floor plate, along with the suspension system and interior components. I myself modified the suspension system to be adjustable for variations in terrain.
I modified the doors because originally it was square windows. Even if it was the handles and stuff, made it look cool. I also designed a dash and modified the steering wheel to help the attitude control.
I was responsible for the overall body of the dune buggy. I created the floor plate, most of the parts were attached to. On top of that, I designed a frame that would allow the new tread system to attach to the body of the vehicle. And I created a new roll cage with one of the aerodynamic flight systems, jet passenger that to the roll.
I decided to make it, took last year's automatic and make it a manual buggy, so I added a clutch and a gearbox assembly. So I designed the pedal assembly and the pedal assembly for the floor plate and made a 5-gear assembly or a 5-gear gearbox, and I also added the option to switch into the aerial.
I modified the seat and seatbelt assembly. I tried to make it more of an ergonomic design, and as far as the seatbelt goes, I changed it to a bar system rather than a belt system. And I also added cup holders.
We're Team C, and our primary task was overhauling the powertrain assembly. When we received the dune buggy, the original file, the engine, the transmission, the electric motor. It wasn't really an assembly, it was more just sort of a random array of parts that weren't really connected in any sort of way. So our primary goal was to get the transmission more functional and to get the overall assembly in order so that we could transfer power from the engine to to the axles, to the drive shafts. And we also made a couple other minor changes as well, but we'll get to those in just a second.
So basically for my part, I had to redesign the transmission. I had to make it smaller and more functional than it was before by adding 17 parts in total, which included 13 gears and drive shaft and a transmission case. This allows for it to connect to the engine, which eventually drives the wheels for the all-terrain vehicle.
And I just designed a kinetic energy recovery system based off of the Ferrari Z1 models, and for the engine attached to the crankshaft, and also designed a computer to monitor the system and control the battery. I also designed a new steering wheel that would house an airbag assembly, and
So I worked with the gearbox assembly. Originally, the new gearbox was just kind of floating in our assembly for the ATV, for the dune buggy. And what I did was I made different clutches and levers to help them connect it to the transmission, so that when you move the shift lever, or when you move the gear shift, it would actually connect to the transmission and change something in the movement of the ATV.
I worked on creating the all-wheel drive axle assembly. The reason for this was that the original design just had a simple axle, so we wanted to improve upon this. I basically researched online to find a design that would be compatible with what we were working with, and created an assembly that consisted of a housing component and a couple of brackets that attached to the body of the vehicle, just made it more stable and improved the all-wheel drive aspect of the vehicle.
I was responsible for the wind turbine. We added this to generate electricity and support the powering of the dune buggy while in flight.
There are a lot of good things I took away from this project. One of the first things I noticed is that the parts that you make for the group project are going to be a lot harder than what you make in lab or in class at any time. So you're going to get a lot of extra practice with that. Another thing that was important to learn is that only about 40% of what you do for this project is going to be actual work in Inventor or AutoCAD. A lot of this is just a presentation, and I think that's a lot like the real world. How you present the information matters a lot. And the third thing was we had to work with group members that were in different classes, so you have to be able to really communicate. We had surveys, we had a Dropbox, we sent out a lot of emails, so it's really nice to work with a lot of people from different classes, because they had a lot of great ideas in addition to great ideas.
Yeah, I'd also say that we got a really good idea of the design process, what goes into planning any particular part you're going to make, all the different factors that go into it, how it's going to sync up with other parts, and how important the dimensions are with all of those parts combined.
Something I really enjoyed about this project was that I really enjoyed wasn't constrained to the world of physics. So we were able to kind of use our imaginations and design something that was really cool. For example, we made a flying dune buggy that had treads and limbs and a wind turbine and things like that. So it's really cool to be able to design these things and not be constrained in the world of physics, and just to use our skills and modeling skills to design whatever we want.
Some things that I think could be improved in this course are, as far as meeting times go, it's really hard to coordinate a bunch of students from 3 different classes. So if Dr. Dixit had any way of better coordinating times and meetings between groups, that would be great. Additionally, I think he could lighten up on his grading style a little bit.
Some of the improvements I would like to see in the class are, for a lot of its instruction, Dr. Dixit's instructions, I just think it would be nice to have a visual example in addition to the instructions he gives us, because a lot of times we're not so clear about what he wants from a project. So if we had a template or an example of like the previous projects, I feel like the class could do a lot better if they knew what to go towards.
Some advice that I would offer to incoming students is to take the lab seriously. They really give a good foundation for what you're going to be doing later. And if you're behind in the labs, you're not going to know what to do with your project.
I'd also recommend that for 3D CAD project, manage time as well as you possibly can, that you're not stuck in last night finishing the project, pulling all night, trying to get it done.
Also, for the 3D CAD project, when you're working on compiling submissions and you're, I guess, collecting pieces of information from other group members, you need to make sure that you set hard deadlines for when you want them to get that information over to you. And if you don't have that information in time, you should just submit without it and notify Dr. Dixon.
Dropbox is really useful for this course. We had over 300 files shared that build up over 2 gigs of space. So it's really good to have a collective place to put all of your files together wherever you can view them.
I'd also recommend to not underestimate how long a hyperlink can take in the final submission, because it takes several hours.